We're going to switch gears slightly and we're going to talk about exponents. But we want to talk about exponents in a practical manner. So we're going to talk about exponents in relationship to compound interest. Now, compound interest is all around us, whether we like it or not. Most of the time, we do not like it because it hikes up our bills and makes us angry and all sorts of things. So compound interest is the type of interest that accumulates on your credit cards, your student loans, your mortgage, your car payment, whatever it is where you're paying that sort of thing. It's the bane of everyone's existence, essentially. So let's get in how to calculate things. We're going to look at it from the perspective of investing, since it's a little bit happier, and we want to do something that people actually enjoy. So compound interest is given by the following formula. And just so that you know, the variables represent different things. The P here is going to represent your principal, or the amount of money you initially invest. So you're going to take your principal, your starting amount, and you're going to multiply it by parentheses 1 plus R. R is going to be your rate, and the rate at which you either accumulate or owe money. So the thing to keep in mind with your rate is that this is usually your APR. You always want to change it to your decimal. So if you had something like 5% APR, make sure you're changing it to that decimal by moving it over 2 spots to make it 0.05. Okay, essentially. And then we have this new variable n. N represents the number of times you're compounding per year. So number of times compounding per year. And your problem is going to tell you how many times you're compounding per year using a word. What it's going to do is it's going to say, I'm compounding annually, or I'm compounding monthly, or I'm compounding daily. What that tells us is that how many times a year we're compounding. So if it says annually is just once a year. You only have birthdays once a year, right? Okay, you have them annually. Monthly, how many months in a year? 12. Okay, so 12 times a year, January, February, March, April, 12 times a year, you're compounding. Yearly would be 365. Quarterly would be 4 times a year. You have 4 quarters in a year. I think that's pretty much everything that you're going to be presented with. There's a few other ones. And then as an exponent, so be careful, this is an exponent, we have t times n. So we're going to take the time that we're investing this money into that account. We're going to multiply it again by that n value. And that, I'm really sorry about the pounding, guys. They're working downstairs. If you can hear that, I'm sorry. Hopefully it's not too distracting. But t times n is the number of times you're compounding. Okay, so suppose you deposit $1,000 in an account paying 4% interest per year, compounded quarterly. So remember I told you they're going to tell you how many times you're compounding. So here we're compounding quarterly. Find the amount in the account after 10 years. How much interest is earned over the 10-year period that you're investing in? So it's a compounding problem, so we're going to use that formula. Best thing to do is just rewrite your formula, get used to it. It helps you to memorize it as well, the more times you write it. N times T. So the first thing is the principal. How much money are we investing? Looks like $1,000. What's our rate? Now, you say 4%, but what should we put in for R? Remember, we've got to change it to that decimal. It's supposed to be an arrow. It looks like somebody's sad drawing of an arrow. There we go. Okay. And then we have to divide that rate by n. So n is the number of times you're compounding. How many times are we compounding in this problem? Well, we're compounding quarterly. There are 4 quarters in a year, so we need to replace n with 4. And then up here in our exponent, I'm going to go ahead and throw this in parentheses, and you'll see why in a second when we use our calculator. So n is 4, and t is going to be 10. So let's grab our calculator, and this calculator is available for download for free if you need it at the front of our course. So 1,000 times parenthesis 1 plus 0.04 divided by 4, close parenthesis. Remember, those parentheses are going to make a difference, as is the zeros, right? So be careful. Now, exponent, on this calculator, it's y to the x. On your calculators at home, it might be that up arrow. So there's that up arrow right there. So that it might be that as well. Play around with it. If you have questions on that, let me know. Now, for the exponent, I actually want to put it in parentheses as well, because that whole entire thing, 4 times 10, should be in the exponent. So we have to throw parentheses to indicate it's all up there. Okay, so it looks like we're at 1,488.86. 1,488.86 dollars. So that's how much is accumulated in the account. So after a certain amount of time, that's how much money is in that account. But if you look at that, that means you started with 1,000, you ended with $1,488, meaning that you gained, or the interest that you actually got was only $488.86. Okay. This one's similar. The only difference is that you're compounding annually. Annually is once per year. So I'm going to quickly do this problem. 1 plus r over n raised to the nt. So again, our principal is our starting amount, which looks like $6,000. My rate is 3.1%. What is that as a decimal? It should be 0.031 divided by n. Now my n is just 1 because I'm compounding annually. Again, 1 times t. It looks like I'm investing for 5 years. Go ahead and just throw that right in the calculator. The cool thing I actually learned about, if that was too fast, apparently in YouTube you can half speed, you can double speed stuff. It's pretty cool. I don't know if you guys have played around with that at all, but in math that's actually pretty advantageous. Because sometimes I feel like I talk slow. I'm like, oh my god, this must be boring to some people. But, you know, some people enjoy the slower and the faster. Up to you guys now. Woohoo! So we go ahead and plug that in, and you can see that it's $6,989.48. Let's round that up. $6,989 and 48, I believe. Okay. So you did gain $989.48 in this example. So not too bad, but that was over 5 years' time. So over 5 years, that doesn't feel like very much. Okay, so I want to switch gears slightly. So if it's compounding monthly, annually, quarterly, daily, you would use that first formula. But there's also this concept of compounding continuously. Now, compounding continuously is where they just keep on compounding, you know, just doesn't stop. And to figure out how much money you would make if you did compound continuously, is you could do a huge amount of numbers in for n in that last example. But there is actually a different formula you should be using to calculate this. I like to call it the Pert Formula, just for a way to remember it. But essentially it's A equals P times E to the RT. Now P is your principal, right? That's still how much you're investing. E is a number. Now, I don't know if you guys were aware of this, but E is like pi, so it's kind of like pi. It's a constant number. E is 2.71. I don't have E memorized. I'm going to be honest with you guys. 2.71828. 1828. Keep on going forever. It's a constant. It's Euler's number, Euler's constant. Feel free to research it if you want to, but it's just a constant and it's in your calculator. It's in all of your calculators, just like pi is chilling in there. So you can just use the e to the whatever button, e to the exponent button. And then you'll raise it to the rate times the time, just like we did before. So they're similar variables. The only one different is that e. And I'll show you where to find it on our calculator as well. So suppose $5,000 is deposited in an account paying 3% interest compounded continuously. Be careful that you're reading these closely, because if you miss that continuously, you may pick that first formula and things are going crazy. Okay, we don't want to do that. So A equals Pert. See where I'm getting that Pert? I feel like I'm like washing my hair in that Pert shampoo or something. Anyways, so let's go ahead and use that formula. P is your principal, which is 5,000. E is E, doesn't get replaced with anything. Well, there's a button for that on your calculator. R is going to be your rate. Now it's 3%, which of course we need to change to 0.03 since it's a decimal. We're going to multiply by T, which is the time in years, which is 5. Then we're just going to plug that all into our handy dandy calculator. Boom. 5,000 times. Now, this button, this calculator has an e to the x button, which is awesome. Super handy. So we just hit e to the x. And it actually does the exponent for us. And then we just plug in our exponent, which is 0.03 times 5. Close that exponent. And we see we have $5,809.17. 5,809. Was it 8 cents? Hopefully. I'm not totally off there. It's okay. So this one we did make about $809 in. Quite a bit more money there. Not bad. Okay. This last problem, we want to go a little bit different because it's asking what the present value or the P is, your initial starting value is, if you had made it grow to $7,500, that's your accumulated amount, at an interest rate of 4.5% compounded continuously for 6.5 years. So of course, as soon as it says compounded continuously, we go, gotta grab that Pert formula. Gotta shampoo my math. These are terrible jokes, guys. Okay, so remember that we're changing what goes in where. So the $7,500 actually goes in for A. So we're going to replace A with $7,500 this time. We don't know the principal amount this time. That's what we're trying to figure out. But we do know E is E, 2.71. And then R is going to be 4.5% as a decimal, which is 0.045. Multiply that by 6.5. So we need to actually calculate that value first. Actually, we don't. Actually, it would be better to just divide both sides by e to the 0.045 times 6.5. And that will cancel, and you'll be left with P, and all we got to do is plug that into the formula. The only reason I don't always teach that way is because that just takes forever to write, but you know, that's okay. So 7,500 divided by e to the x, so hit that e to the x button. In the exponent is 0.045 times 6.5. close parenthesis, hit enter, and it looks like $5,597.96. $5,597. I don't know, 67 cents. I'm making this up. Okay. So, I'm making up those cents. Let's double check. It's totally off. It was 96. What am I coming up with? 96 cents. Great. We're all going to pretend that was there to begin with. Okay. So it looks like we need to initially invest at least $5,597.96 to get to that $7,500 goal. Okay, so that's kind of the use of this formula, right? Working this way, we can figure out what we need to start with to where we want to end at. So keep working. Make sure you're identifying the difference between the compounding formula, the one we did in the beginning, and the compounding continuously formula that we did at the end.